Quality webinar presentation. Pablo Baez with ASQ's Body of Knowledge team. Our presenter today is Jim Rooney. Jim is the Director of Quality Management and Lean Six Sigma Services for the Public Sector Division of ABS Consulting. He has more than 30 years of experience in quality, risk assessment, and process safety management for many industries, including chemical processes, pharmaceuticals, petroleum medical devices, and nuclear weapons, just to name a few. He's also very active at ASQ. He's a fellow and holds 10 ASQ certifications. He serves as the treasurer of the ASQ Board of Directors, and in July, Jim will take on the position of President-elect of ASQ. Back to finish the second in a two-part beginner series on search for and topics on ASQ's website, root cause analysis. So without a delay, let me pass this over to you, Jim.
Overview of what we did during the first webinar. The first was a focus on really philosophical issues. We talked about human error and the causes of human error. We delved into performance shaping factors, those innate and external factors that lead to human performance. We ultimately talked about the relationship between human performance and the management system. The management system guides the actions of the enterprise, guides the actions of our employees. The management system essentially sets forth the conditions under which our humans perform, and is responsible for their errors. Today, to move into a more practical realm, we'll talk a little bit about root cause analysis, what it is, how to do one. We'll talk about the quality tools that are available out there for you, and we'll talk a little bit about some of the data that you need to collect. Today's will be much more useful to you in a practical sense. What is a root cause analysis? Method. Essentially, it's a process that we're going to follow. We investigate an incident or a series of incidents. So you're talking about investigating or explosion or a series of chronic quality problems in the door panel. The tools we'll talk about today are applicable to both of those kinds of problems. What we do is understand the causes of the incidents, including management system issues that cause or lead to the incident. We want resources wisely in both performing the root cause analysis and ultimately in coming forth with recommendations to prevent the events from happening again. We take these corrective actions, and we also hopefully mitigate the events. We identify changes to management systems as our #1 priority in preventing events from happening again. Well, what are the relationships among analyses, operations, and management systems? We touched upon this a little bit in the first webinar, but I believe it's a good review and also a good point to amplify it a little bit. In the world, we've done active analysis on our system, whether it be hardware or software. We've analyzed our procedures, our hardwares, to think about what can go wrong, what are the causes of the incident, and essentially we're going to take that information from our analysis before we've even operated our system information and create our management system. So essentially, our management system is going to make equipment and the human behavior within the system. Whether equipment design, centered maintenance strategies, our administration processes, procurement, employee screening, all those things. And ultimately, the management system controls the operation of the facility. And the goal to operate our facility in accordance with our management system, because our system is in fact our best faith effort in a way to minimize benefit and minimize losses from our operations. In world, nothing bad would happen. But in the world, there are failures, losses, and inefficiencies. Damage, hurt individuals, damaged individuals through either the manufacture of the process or use of our product. Coming out of those unacceptable failures, we're going to perform active analysis, our incident investigation or root cause analysis. As we look at the block for reactive analysis and compare to the proactive block, you'll notice that the questions are very, very similar. How did things go wrong? What were the consequences? We're going to use our structured process and our tools to figure out what went wrong and ultimately to identify the changes that should be made to the proactive analysis process and also to the management system. So we want that information through analysis back into our proactive analysis and our management system. Now, most root cause analyses do provide information to management systems. The link that's usually non-existent or the weakest is linkage back to the proactive analysis, because the team that has done that during the design phase has been disbanded. But if those individuals are still around, or if you have a document management system, it's great to record those pieces of information for the next time you go into a design phase. That we are process from proactive analysis through the management system operations and active analysis feeding back to the beginning of our process. So comes what management systems control. What control do we want over our operations? We can't control everything. It's an attempt to control everything, and there are certain things where the consequences are very low or the frequency is very low, and you really don't want to spend a lot of resources controlling. So control those incidents that cause intolerable pain, whether they be fatalities to your employees, whether that be dangerous products, unusable products. We want to focus on those things that can affect our stakeholders, whether that be our stockholders, our employees, our management, or our regulators. We want on incidents with the highest risk, a combination of frequency and consequence. So we're not going to look at just high frequency events or consequence events. We're looking at that doublet of frequency and consequence and making sure that we understand which events are the highest risk, and we're going to focus on those. Talked about, there are a number of proactive analysis you can take to identify high-risk issues even before you begin operations. Some are listed here. Hazards and operability analysis, and effects analysis, which is used very extensively in the pharmaceutical and auto industries. Reliability-centered maintenance, tree analysis come out of Boeing in the 60s, used for risk assessment of airplanes, ultimately used by NASA for the shuttle, Nuclear Regulatory Commission for nuclear reactors. What's a very straightforward technique, easy technique to use. So obviously we can cover a wide variety of problems with tools. Talking about levels of investigative analysis. And we really want to spend the time to look at issues in our plan. Out and take a quick little snapshot of operations. What you'll see is individual error or equipment failure. So we're going to see performance gaps, whether they be for frontline personnel or whether they be for equipment. The here are performance gaps for frontline personnel there on the right-hand side of the slide. But for us, we need to go all the way down, further than our triangle here, our pyramid, to really understand what's going on. So we'll increase the depth of analysis, increase the level of learning, when we increase the scope of our corrective actions. So hopefully we're going to go beyond our individual error or equipment failure and really move down into task control and process control issues. What issues are there that have been causing issues? What not being executed properly? Safety. Really, we'll be looking down into the management system itself and looking at how the management system is organized and developed, and really trying to understand what the performance gaps are for our support organizations. At the top of the pyramid, you see organizational cultural issues, whether the organization's attitude towards safety, quality, reliability. Analysis and its recommendations usually don't have a direct impact on organizational culture, but it is through the use of root cause analysis over an extended period of time, you're going to have more and more impact on management system issues, employee, the company responding to problems, and hopefully they will respond with a positive attitude, and organizational culture will change and modify over time to be better. But what we're trying to do here is we're trying to get away from blaming the individual, from blaming a part, and really understanding the management system drivers through programs and procedures on our plant's performance. The real goal of root cause analysis, we set people up to succeed instead of setting them up for failure. We want our programs and our procedures to make so that they're not error-likely situations that we put people in, that we put them in success-likely situations. So ultimately, the goal of a root cause analysis is the same as we had in proactive analysis. Let's take a minute or two to look at an overview of a root cause analysis process. And what you're going to see here is a generic process that we've used many times and is really good for managing root cause analysis and your incident investigations. When it happens, you have to ask yourself the question, do you analyze it now? Obviously, if the consequences are big enough, you're going to move forward. You initiate the investigation. You're going to chart a team. You're going to attempt to control the situation. You're going to attempt to control the location where the event happened. But here is really our kickoff in identifying what our plan is, what our problem was, and putting our team together. We're going to spend time going out. We're going to interview people. We're to interview pieces of equipment. We're going to look at computer logs that are levels, temperatures, that whether or not feet change state, valves go from open to closed. We're going to spend time gathering data. Ultimately, we have to analyze that data. Now, if you go back to the proactive analysis slide, there were tools there that we talked about and that we use to analyze our data. And we'll talk about them some more here in a second. We're going to look at root causes. As we work through the process, though, it's going to drive us back to gather more data, to analyze data. So as we bring forth candidate root causes, we will send people out. We'll send our leaders into the field again to people, look at more positions, look at more parts. we're going to develop recommendations. And this is what we've been after the whole time. This is the most valuable output from our analysis. Also, there's a follow-up and a resolution of our recommendations. Now, at this point, the follow-up and resolution of the recommendations usually is more responsibility of management than the cause analysis team. Our team is usually going from the initiate investigation through the development of recommendation steps. The box on the end and the diamond at the beginning really are functions of management. Now, here that I've just brought in for you to look at. Obviously, if you decide not to analyze an event, you need to trend it. So obviously, you're going to characterize it as whether it's quality, reliability, did it involve human, did it involve a part, what, and ultimately, we're going to trend the incident that we analyze. There may be a point where there is no trend, and there is no analysis that's taken. But as we do the ending, we enter this information into an incident database. And time looking at that data to find chronic incidents. Incidents happen at frequency that aren't really high consequences. They're low to medium, but frequently enough to really cause us a loss. And we want to look at those. And obviously, we'll trend the incident characteristics. We're also going to trend root causes. What we're trying to do here is manage the process so we know what we're going to analyze immediately, trend, how we select out of that trend analysis, and in the investigation there. Sometimes trend root causes to see, are we having a lot of problems in the management system for procurement? Well, maybe we want to do a special analysis to review the entire procurement management system. We may look into our reliability-centered maintenance program if we believe that there have been problems in the design, setup, and operation of that system. So here's our overview of root cause analysis. The goal is to get those recommendations, those golden nuggets that we're after to improve the performance of our systems. This is our overall root cause analysis program management system. So we're back into the idea of a management system for root cause analysis. So you can be surprised about that, given the emphasis we've had through both Part 1 and Part 2 on management systems. If we're going to, we need a system to manage it. I want to bring data. This takes the most time during your root cause analysis to go ahead and find these various things. I want to talk about the various types of data that we have. Obviously, there's people. We have to review them. We have to figure out who to interview. Obviously, people are information for us, but we remember that people are easily influenced. Forget rather quickly details. So even though there is no overt influence on people, if they get together and discuss what happened during the event, kind of out amongst themselves, and that changes their viewpoint of the incident. The group really understands the process, and they put forth an explanation before there's been any analysis done. People look to that expert as the right answer. So you can interview people relatively quickly in a non-threatening environment. There are valves, open, closed, modulating. When you think of where are people during the event, if you have where are the fragments, there's lots of position data to think about. Data also can be somewhat fragile. It can be cleaned up. We can essentially try to get back to an operating mode, change the positions of valves, change levels in tanks. Paper and electronic data, this stuff isn't very fragile. It's for years. It may exist for decades. Paper in particular goes into files, goes into people's desks. So it's hard to find, but it has a long life. The other thing about paper data is it's very hard to manipulate things that are 10 or 15 years old. So it provides a very unbiased look into what the system was 10, 15 years ago when we set up our management system. Electronic data has slowly been replacing paper data over the last 20 years. So many of the things about paper data being put into a form are very similar. You're finding multiple computers. I'm a pack rat engineer who keeps every file about every piece of equipment in my system. You have to be able to find it. There's physical data. About this is going out and taking a lube oil sample to see if it's been contaminated by metal grit. We may and sample our product. We may test our product to see what its performance is. Physics also has a tendency to degrade over time as the environment may impact our, say, a pharmaceutical. What I'm trying to do with this slide is show you a way to categorize data and think about data. There's a lot out there, and that is one of the things that really examines a good root cause analyst. They think about these various categories and ask the right questions to uncover the data as they move forward through their analysis. Analyze the data. We've written down every piece that we've found, every part that we've tested, try to put that into a coherent framework for us to understand. I want to talk about some of the tools that are out there. Not to make you an expert on any of these, but I really do want to point a number of them out to you. One is tree analysis. Begin with a known event, and you describe possible combinations of events and conditions that can lead to this event. You'll recognize this as kind of an advanced form of the 5 whys. We're still some top event, my car fails to start. Ask, why did my car fail to start? And you can see right now, well, this is kind of like a troubleshooting guide. You know, what was the problem in the starting system? Was the problem in the gasoline flow? Was there a problem in an electrical system? What we're doing here is we're doing structured guessing. And actually we're going to go out into the field and look at various components and say, I tested the starting system of my car. It worked. Obviously, that can't be the cause. I need to go look at the fuel system and investigate the fuel system. What we've got with fault tree analysis that's better than the 5 whys is and or logic to show the causes and the combination of causes. So when you think about it, we can get not single events that might cause my car not to start, but we also get those combinations of 2s and 3 events that might cause my car not to start. When I'm doing proactive analysis using fault trees, what I'm going to do is identify every possible failure combination under the sun that could cause my car not to start. But what I'm trying to do in root cause analysis, I want to come up with the smallest tree. I want to ask those questions starting at the top that use data to prove or disprove the various branches. So I don't want to draw a giant fault tree. I want to right, as I said before, the starting system, my test it is fine. I'm going to break the starting system down into tiny little failures, looking at starter mode or looking at the battery. Waste of my effort. I'm focus on the fuel system. But ultimately, my goal is to identify the performance gaps of equipment and frontline personnel. If you're interested more in fault tree analysis, there was an article that I wrote for Quality Progress magazine. It was published early in 2009 that really talks about using 5 whys in fault tree analysis. So it would be a good thing to go look for in the Knowledge Center. Here's a simple fault tree from the field. So it's not only for hardware and equipment. We have incorrect gas delivered to a patient. Why does that happen? Delivered through the system and the error not detected at the patient location. You can see that we keep asking why and working our way down through various combinations. You can see from the lower left-hand side, though, that we were able to show that tank filled with incorrect gas connected to the system did not happen. That's that oval there with the no symbol. So there were a number of things on this fault tree that we were able to show could not exist. We also had to put questions on there about looking at the tank with correct gases not sufficiently mixed. Why? We wanted to talk to the supplier. Ultimately, as we work through this analysis, we identified 3 things, 3 causal factors, not root causes, causal factors, which are the equipment or the frontline personnel errors that led to the event that caused incorrect gas. So we've got a tank error not detected at the point of connection, the tank gases not sufficiently mixed, the oxygen monitor not being used. All 3 things happen for incorrect gas being delivered to the patient. One of the big tools that can be used is causal factor charting. It's a little than fault tree analysis in that it's better time relationships. It kind of is very similar to a timeline, but a line with logic. Basically, what we're trying to do here is to show cause and effect relationships and use various logic tests to ensure a complete understanding of the incident. Because it brings together the data collected from multiple sources. So from our people, from our position, from our physical, all comes together on causal factor charting. Again, we have the same goal, identify those performance gaps of a frontline personnel are causal factors. We have an equal causal factor chart. If you look inside, you'll see that we have a black event, which is in fact our loss event. A tank was injured from a spinning centrifuge. Well, ask yourself, what happened immediately before that? If you look to the left, you can see the technician immediately reaches into the centrifuge to remove the sample. Bottom of that little block there, that building block, we tell you that that happened at June 21st, 2004 at 14:05. And that was observed by person LT. So on this chart, we have our piece of data about the technician. We know when it happened. We know where it came from. And as you look back to the left, what we're basically doing is asking what happened earlier and earlier in our sequence. Going all the way back in time to April 2002 when the centrifuge was purchased. And that we got that piece of information from our purchasing records. Thing on here, you can see the ovals again where we can post our questions right on the causal factor chart. If you haven't guessed it already, causal factor charting makes great use of post-it notes. So you can use post-it notes to begin doing your causal factor chart, starting with that loss event, look back in time, write the various pieces of information on your post-it notes, using different colors for for interview requests. What we do is when we finish our causal factor chart, when we believe we truly understand the event, we ask ourselves, what are things that if they had happened, those equipment or performance gaps, that if they had happened, the event wouldn't have happened. And you can see here from the graphs that we've got two. Illuminate while the centrifuge is still in motion. That factor, and centrifuge interlock disengages while the centrifuge is still in motion. That causal factor. Those two things happening move towards the technician's hand being injured. So you can see here, time progresses from the left-hand side to the right-hand side, and we come to an understanding of the event. Again, not trying to make you an expert in causal factor charting, but to let you know that this example, this is out there. And again, there is an article in the Knowledge Center on the basics of root cause analysis that will take you through how to do a causal factor chart in detail. A quick comparison here between the two different tools, causal factor charting and fault tree analysis. They're both good for acute incidents. It's really better for chronic incidents. Factor charting can only characterize a typical incident. If you know people-oriented problems, causal factor charting is the best. Incidents where timing is very important, you want to use causal factor charting. Analysis is not useful for incidents where timing is important. If you're somebody who's worried about your diesel generator starting and then running, and is kind of changing configuration from a starting configuration to a running configuration, using fault trees, you want to be using causal factor charting. But if a system that's running in a set state for a quick analysis is the best. People who are good at causal factor charting use causal factor charting for everything. Issues. Same thing with fault tree analysis. If you invest in learning the technique and use it, you solve every problem with it. It's a matter of, for those people who don't do a whole lot of causal factor charting or fault tree analysis, they should really use the tool that's more appropriate to the problem. Now, that for fault tree analysis, and this is in the article in progress that's about a year old, there's a regulatory handbook, fault tree handbook, that's available from the New Regulatory Commission for free as a PDF download. Very valuable resource. So that is a good place to start in learning about fault trees. So the question that I ask myself is, which of the types of analysis tools do you currently use for your root cause analysis? The answer comes back, you are using 5 whys or time. Many don't move into using the more formal technique of fault tree or causal factor charting. The reason to use the more formal technique is 5 is fantastic if you're an expert in the system and you know through engineering judgment what problems are going to be. But for somebody like me who comes in from the outside, who may know very little about your system, I'm much better off using one of the advanced techniques. So if you're going to be an investigator for your company and going to various plants, various processes that you're not familiar with, you want to use the fault tree or the causal factor charts. And for simple problems, 5 whys, what-if checklists are excellent. There's no reason to drive yourself to the more complex tools just to be able to say that you used one. The others are more than sufficient and fine. We now to a really important part. We found what the equipment failures were, what the performance gaps were that caused our problem. But now to make that transformation into what are the issues with our management systems, because efficiencies in management systems are our root causes. So cause every incident that some improvements in management systems could have prevented most or all of the contributing events from occurring. Think back to some of the most famous incidents that have happened in terms of, if you think of Chernobyl, if you think of 3 Mile Island, if there had been improvements in their management systems, those events most probably would not have occurred. Because when you think it's the absence, neglect, or deficiencies of a management system, those are fundamentally the cause of incidents. Address root causes because we want cost-effective solutions to problems because the solutions are implemented. We want to efficiently use our resources. What we're going to see is we're going to provide a leveraged solution that prevents or mitigates many past and potential incidents. So make an improvement in our reliability management system for pumps in a unit. Hopefully, we're going to modify the management system. That improvement affects every pump throughout the plant. Not only every pump, but every valve, every column, every machine that you can think of. So that's why we're trying to address management system issues, so that those corrections and improvements are process-wide, facility-wide, maybe even company-wide, rather than just focusing in on improving my one little pump in my one unit. Yes, I know this. This is our map. It's available in the Base of Root Cause Analysis article that Quality Progress published a number of years ago that's available from the Knowledge Center to members and non-members at no charge. I really want to point out from this is really a structured flow chart to start at the top with your equipment problem and essentially ask yourself questions you down to the ultimate root cause. So, your contact root at the top, you ask yourself, is it an equipment difficulty? Is it a personnel difficulty? Is it some other difficulty? Well, if it's a personnel difficulty, then obviously we're in the middle of the map and we're going to ask ourselves additional questions about whether that was a contract employee or a company employee. That ultimately leads us down to asking questions about, is it human factors? Is it training? If it's training, was the training done? Was the training not designed properly? And ultimately, we can take an issue from a performance or equipment performance level at the top and go down to a management system root cause. Now, this thing that you can see, and this is uniformity across your organization in the way that your root cause analyses are done and your root causes are identified. Because along with the root cause map comes a page of description for every decision block and every root cause on the map. So you understand completely what someone means by human factors engineering. What it means the development program being less than adequate. These ideas are explained and examples are given for each root cause. In addition, information is given about the typical recommendations for management each root cause. So again, we're trying to help people move forward in identifying root causes, and ultimately the recommendations. Well, recommendations want to be and cost efficient. We've spent a lot of effort working the analysis, identify those root causes, and now we want to develop recommendations. About some characteristics of recommendations that you need to think about as you develop them. The first, timing of them. Some are term, some are medium term, some are long term. Maybe some short-term recommendations that we implement immediately in terms of quickly modifying a procedure. There will be some long-term improvements or specify a new computer control system for a pharmaceutical manufacturing facility. Obviously, it may take a year to get the capital request in, another year to do the design. We have to go to purchasing. So those things may take many years to get done. Another idea is to think about recommendation levels, okay? And we like to think about it as 4 levels. The first is to address the performance gap. We want to address that causal factor, that human error, or that equipment failure. And these are usually very short term. I have to go out and I have to fix my pump. I have to fix my valve. I have to do that to get back up. We want to address the underlying cause of the specific problem. So what was it that led to that valve not working? And I want to make sure that that portion of procedures or maintenance procedures are fixed. I then will go to level 3 and think of fixing similar existing problems. So taking the idea, moving it from valves to computer systems, to new system procedures. How do I fix similar existing problems? Ultimately, I want to back and correct the process that created the problems. So I'm going to say, what was it about the procedure development system that wasn't right that allowed us to put forward a maintenance procedure for valves that was not correct? Because I want to fix that process so that I do that again for any type of piece of equipment in the plant. So I've got a production system, push product. We've got the production system left putting out these pieces of product. One have a problem. I don't know, but I know that that one does. Level 1 and 2 recommendations are focused on fixing that bad product now. My level 3 recommendations really look at the other products that I've made and what we need to do to make sure that they're okay. But ultimately, my level 4 recommendations are about my production system. How to change my production system so I don't produce bad product. Now, let's take over and think about management systems. I've got a management system, and it's making products. You don't think about them that way because it's like making a car. It's not like making a television. But management system procedures, management of change packages, trained operators, designs for new systems. So our management system, it's making products. Products has an issue with it. We've got a procedure that's not right. We make procedures that are not right. So the 1 and 2 recommendations are with respect to that specific procedure or procedures to correct that. We want to look at other procedures, but ultimately we want to back and fix that management system so we all produce correct procedures. We have a little bit of an eye chart here, but this is a very useful tool for presenting your results to management. And what here is what we call the root cause summary table, or more commonly known as the three-column table. Describe causal factor, the failure or the human error that caused the problem. And the causal factor here that's described is that the control room operator failed to contact the building operator, and as a result, there was a valve that wasn't closed. Very quick what the factor was, what our error was, and we provide some other information, some background there about the control room, about the uses of various communication tools. Then present management our through the root map. I'm going to let management know how it goes as we went through that graphical checklist through the root map, starting at the top with our causal factor, working our way down to the management system issue. And here, that possible path through the map is the fact that this is a personnel difficulty, it was a company employee, it was a communication issue, the communication was not timely, and ultimately the method of communication was unavailable or less than adequate. In essence, the telephone system was already in use and there were alternative methods available for personnel. There's also a second possible path through a difficulty, a problem, and design output. The design didn't address all the communication needs in the facility and capacity not available through using the current system. We make sure that our recommendations address the root error, the available as one root cause or design input output. If you look at the bottom of the recommendation column, you can see that one of the recommendations directly addresses design input output. We're in the design process to ensure the needs of users are solicited and addressed. So this is a long-term recommendation. It's a level 4 management system recommendation. Inherent reliability of the system, and the stability is engineering. So what we're doing here is we're presenting management in a concise way what our causal factors were, what our management system deficiencies were, and what our recommendations are. So in one table, management can see one of the outputs from our analysis and see what logic is. So they understand why we asked for a particular recommendation. So it gives you that very tight linkage between the causal factors, the management systems, and the recommendations. This gives management great faith in your recommendations. Now, engineer now has been the fun part. We're solving problems, we're getting data, we're talking to people, we're figuring out what's going on. And then with the big bump in the road, the fun's over, we've got to document the analysis. As I want to do the first bullet, I want to minimize the effort to develop the report, okay? And that's why I really like the causal factor chart in the fall tree. It provides a gradual of what happened and how it happened. So I always need to write 20, 30 pages about the event. I can write a couple of pages summarizing the event and use the causal factor or the fault tree to provide the detail. So as I'm doing my data analysis, as I'm working towards my root cause analysis finished by doing a fault tree, I'm really working on the report. Again, to use that 3-column form. It gets you right through the performance gap, the root causes, and the recommendations. It helps me organize my thinking during the execution of the root cause analysis, and lo and behold, again, is a product that I can give to management. I like to use a standard report, 6, and you'll all come up with a report management will be happy with. What I do here is to take you through from the of root causes. Errors occur, how human errors really influence equipment failures, and the linkage of those two to management systems. Management systems being the drivers, being the controlling factors in the operation of our people and our equipment. So ultimately, we want to use tools to identify management system deficiencies of root causes to improve our operations. There are tools out there that you can use. What if checklist, FME, fault trees, causal factor charting, whatever you think you need to match your problem with the right tool, use a management approach, causes, and do your recommendations. If you have questions, you're free to contact me. I know Pop spent a minute or two talking about that's available from ASQ, but the wealth of information that's available for free from ASQ for members, from Progress Quality Engineering, that can take you through any of these tools and take you from being a beginner to an expert user. I thank you very much for attending both of these webinars. Again, Pablo will tell you how you can contact me, and I'll be glad to help you in any way that I can. So Pablo, I'll turn it back over to you.
Thanks. Thank you so much for that great overview on root cause analysis. It's an increasingly popular topic, and so I know it'll be well received and appreciated by our membership. To learn more about him and ABS Consulting, you can check out his contact information here. And to learn about ASQ's information on root cause analysis, including articles and podcasts and webinars, tools and templates that will be shared with this event and others like this one, check out ASQ's Knowledge Center, which is www.asq.org/knowledge-center. Thanks again. Hope to see you at the next event.